Okay, algebra kids, I'm home with a sick kiddo today. You might hear her squawking here at some point. So 6-2 is what we're going to do today, and this is all talking about inverses. And I'm not sure if you guys had inverses. I'm sure you probably did in Algebra 1. But inverse functions have to do like with if, let's say we have, I don't know, x squared equals 4, and we are trying to undo the x squared to solve for x over here, we would apply what's called the inverse, and we would take the square root, right, of each side, and then we would solve for x, and x is like plus and minus 2 and all that good stuff. So when we have like x squared, the inverse, or the thing that undoes it, is the square root, okay? And those are things that are called inverses. Same thing with, like down here we have, like if the original function is x minus 5, the thing that will undo that is x plus 5. Those two things are inverses of each other. Now let's take a look at the notation that they use. F of x, we're used to saying that, but the notation that they use for the inverse looks like f to the negative 1 power, okay? That's just the notation that they use for inverse, for undoing things. F to the negative 1 power of x. That's kind of what it looks like. So we are going to be finding those inverses today. Before we do that, they are going to give us a non-equation, so a non-function, that is just ordered pairs, okay? And so when we're trying to find the inverse of ordered pairs, they've graphed those three for us. So 2, 4 is this point right here, 2, 4. Negative 3, 2 is this point, and 4, 1 is that point, okay? If we are trying to find the inverse of coordinates, it makes it really nice because all we have to do is just flip these two coordinates around, okay? So instead of 4, 1, we would graph the point 1, 4. And so C inverse will be 1, 4. I'll do B inverse. Instead of negative 3, 2 will be 2, negative 3. And then A inverse will be, instead of 2, 4, will be 4, 2. And let's graph those guys and we'll see what it looks like on the graph. Let me get rid of all these other points here. Okay, so let's graph those 3 points. So 1, 4 this is where C inverse is. Okay, 2, negative 3 is down here. That is B inverse. And 4, 2 is A inverse. Okay, so, did I do that right? 1, 4, 2, negative 3. Yep. Okay, so I've got this thing going on here. So it's taken that triangle and kind of like flipped him a little bit, okay? And the way that this works is that always when you flip these, your figure, whatever you have, will always be kind of a reflection across this dotted line, okay? So it's like whatever's over here will now flip and be across over there, or whatever's over here will flip and be across over there. So he is reflected across this dotted line, and this dotted line is the equation y equals x. It's like a linear function, right? Like y equals x plus 0. If you were to graph this thing, you would start at 0, and the slope is 1, so you go up 1 over 1, up 1 over 1. This y equals x is the dotted line that he's reflected across, okay? So when you're doing just ordered pairs, all you have to do to find the inverse to undo them is to flip them around, okay? So the x becomes the y becomes the x, that type of thing, okay? So that's for ordered pairs. Now we're going to get down into talking about finding inverses of equations, okay? So not ordered pairs, not an x and a y, an actual equation, okay? There are steps to this, okay? So I want you to write these down somewhere. Let's put them right here. So I'm going to say steps for inverse. Okay, there are 4 steps. Step 1, step 2, step 3, step 4. And what I'm going to do is as we do the steps, I'm going to actually find the inverse of this one over here. So I'll list the step out for you, then I'll actually do that step. Then I'll list the step, and I'll actually do that step, okay? These steps are fairly easy. Step number 1 is the f of x that's in your equation. You're going to rename him, and you're going to call him y, okay? So up here, f of x, step number 1, I'm going to say y equals 3x plus 2. That was like really easy. Like I just had to put the y in that spot. Not too bad, okay? Step number 2 is just as easy. All I do is take your x and your y and you flip them around. right? So like the x becomes the y becomes the x. So in step 2, this y is going to now be named x. This x is now going to be named y, okay? So this is my step number 2. All I've done is just like rename stuff, okay? Now, keep in mind we're flipping the x and the y around in step 2, which is similar to what we did for ordered pairs, right? We just flipped the x and the y around. So it's kind of consistent, same type of thing. Okay, step number 3, I'm going to put him in a different color because he is the hardest step. This one is not the hardest. I mean, it's the longest step. You're going to solve for y. Now that y is inside of the right side of the equation, we're going to try to get it by itself. So like we're undoing all of this stuff, finding the inverse. We're undoing and solving for y here, okay? So in step number 3, this takes a little bit of work to do, okay? If I were to solve for this y and try to get y by itself, I have to move the 3 and I have to move the 2. Okay, so we say to ourselves, what do we move first? I'm going to subtract the 2 first. So I have x minus 2 equals 3y. Cool. Still got to get the y by itself. So I'm going to divide by 3. And what I'm going to do is I'm going to divide by 3 in all 3 places, right? In all 3 spots, okay? So I have y by itself over here. This is x over 3 minus 2/3. And this is the y solved for. Okay, now before I move on to the last step, I'm going to show you how they might write this differently. So instead, you can always put your y on the left, back on the right side. So if you want x over 3 minus 2/3, you can flop those two around if you like to have your y on that side. Okay. They might also, instead of writing it as x over 3, they might write it as 1/3 x, because there's like an imaginary 1. So they like slid the x off to the side, so that looks more of like the mx plus b format, right? Okay, and then minus the 2/3 on the end. So they might write it like that instead, where they have the x on the side. They might also instead write it as x minus 2 all over 3, right? So like leaving this as a combined and put the 3 on the bottom of the whole thing. Now, if you're going to graph this, I would write it in this format because it is in the mx plus b form, right? If you were to graph this thing, you would start at negative 2/3 and then go up 1 over 3. That's easier to do than when it's in this format, okay? But I'm just showing you that all of those things mean the same thing. Whichever one of these, those are all equivalent to each other, okay? All right, last step, step number 4. So we've solved for y. We've done step number 3. Check, solve for y, okay? The last step is that the y gets renamed. Up here we renamed him. He was originally f of x. Now we're just going to take the y and we're going to rename him f inverse of x, which is like that -1 power. So for step number 4, it's just a renaming step. Okay, I'm going to go and use, I'm going to use this equation right here, like this. And I'm going to call him f inverse of x equals 1/3 x minus 2/3, okay? So I just basically took this guy and I flipped him back around, okay? So whichever format you want to leave your inverse in, you just rename him and put f inverse of x in there. So basically, the only hard part to finding the inverse is step number 3. Otherwise, you're just renaming things in each of these 3 steps. Like that's the easy part, okay? So there's that. Example 3, we're going to skip over example 3. There's one like that one on your homework assignment, but we're going to do it together tomorrow when I come back, okay? And it's like finding the inverse of x squared, so it's a little bit trickier. We're going to save example 3. We're not doing example 3. We're going to go to example 4, okay? So here's another one. We're trying to convert between Fahrenheit and Celsius. Some of you guys maybe have seen this equation before for temperature, okay? So this is a formula for converting Fahrenheit to Celsius. So like right now it is, I don't know, my clock says that it's 18 degrees outside. Woo, we're in a heat wave. What the heck? 18 degrees outside. So if I wanted to know what that was in Celsius, I would plug 18 in there, I would subtract the 32, I would take it times 5 over 9, and that would give me my degrees in Celsius, okay? Now, if we want instead to have an equation where I know the Celsius, I plug the Celsius in and then it tells me what that is in Fahrenheit, we have to convert this equation and we have to solve and unwind it, finding the inverse, okay? So that's what I'm going to do here. They're doing the steps, okay? So they take this original guy and the first step, step number 1, is taking our f of x and we're calling it y. Okay, in this case, it's t of x, not f of x, but they mean the same thing. So step number 1, we're calling it y now, okay? Step number 2, we switch the x and the y, okay? So now this goes in as y, this goes in as x. That was step number 2. Step number 3 is a little bit more tricky. It's like this stuff here. We are solving for y. So what they've done is, I'm following their work because their work is actually decent this time. If we're trying to solve for y, I need to get rid of the 5/9 and I need to get rid of the 32. But since the 5/9 is on the outside of the parentheses, I'm going to get rid of him first. And what I'm going to do is I'm going to multiply by 9 over 5 because that will reduce him. So times 9 over 5. That's how they get 9 over 5x here. Okay, they put the x on the top, which is totally fine. Or you can leave the x on the side. So 9 over 5x or 9x over 5. The x can either go on the top or on the side. That leaves me with y minus 32 here, okay? I still need to solve for y, still need to get y by itself, so I'm going to add the 32 over, plus 32, plus 32. I can't add 32 to 9 over 5x because this one has an x and this one doesn't, so I'm just going to put plus 32 on the side here. And this is my equation for solving for Fahrenheit, right? If I would put Celsius in here and it would give me Fahrenheit, okay? So step number 4, they've just renamed this y and they're calling it t inverse of x, okay? So I've got 9x over 5 plus 32. They flipped the equations around and then they've renamed him at the same time. So 9x over 5 plus 32, okay? That's how that all works, all right? So now I have the equation where I can plug Celsius in and find Fahrenheit. And that's the benefit of the inverse, right? Okay, and doing it that way, okay? All right, couple more things. Example 5 and 6. Okay, last concept that we have going on here. Let's say I have two functions, this guy and this guy, and I'm trying to figure out, like, are they inverses of each other? Okay. What I could do is I could start with this guy and do the 4 steps and see if he turns into this guy. Or there's another thing that you can do, and that is using composition, okay? Composition means, hold on, we got to help her. Give me a second. She wants to help. Tell me your sister. Oh, goodness. Oh, goodness. Oh, goodness. We're still fighting kind of a little cough. All right. So we use composition, and composition was like that. F composed of G of X and G composed of F of X, right? It looks like fog and goth. Or sometimes they'll use the parentheses, like F parentheses G of X, something like that, right? Instead of using fog, okay? So it's that open circle, which means composition, okay? What I can do is instead of taking this guy, finding the inverse, seeing if it turns into this, what I can do is I can do the composition. So what I'm going to do is I'm going to take... Sister, goodness. Goodness. Are you all right? Oh, that's a big cough. Okay, I'm going to take this like second function and I'm going to plug it into the x here, okay? So if we do that, yeah, that's what they did here. H composed of k of x. So they're taking this second function, x minus 13 squared, and they're plugging it in for this x here. They've done that, x minus 13 squared, but then I still have the plus 13 right there, right? Okay. All right, and what they did was they went ahead and they squared out x minus 13 squared, and when you do that, you have to FOIL it. Goodness, we just can't get our cough out. Poor thing. Okay, yeah. All right, so FOILing x times x is x squared. X times 13 is minus 13x. We have another minus 13x, and that's where they get the minus 26x. And then minus 13 times another minus 13 is plus 169. Okay. They're putting this stuff together and combining like terms. So we get x squared minus 26x plus 182. Okay, now here's the deal. When you stuff one of them into the other, your answer should come out to be x. I don't know if that goes in that spot because it's not the identity function h and k. Okay, that shouldn't go there. This is not equal to x. It should simplify and come out as just x. So like all of this stuff should cancel in here, and it doesn't. And the fact that it doesn't means that these two are not inverses, okay? when I stuff one function into the other, everything should go away and reduce except for x, okay? So let's see on this second one if that happens, okay? So they've given us the equation for volume of a cylinder, and they say it is 5 pi r squared, okay? That's volume of a cylinder. They want it, though, to be solved for in terms of the radius, okay? So what they've done is they've unwound this function, found the inverse, and now they have r in terms of v, kind of like we had Celsius in terms of Fahrenheit. Goodness. Okay, so they've unwound the function, and so we have two different functions now, one solving for volume and one solving for radius, okay? So what we want to do is we want to do v composed of r. We want to stuff the r equation into the v equation. So this stuff is going in place of r right there. I'm like substituting, right? Okay, so we have 5 pi, that's this part, and this stuff is going inside of that square, okay? So 5 pi, this was originally r squared, but it's not anymore. I put that stuff in there, okay? So what's happening here is I have a square root and then I have a square, and those two things are going to cancel. So that's what they've done in this step. We have 5 pi times v over 5 pi. Now, these two 5 pi's can cancel. One's in the numerator and one's in the denominator. Those will cancel. So I have v left over, okay? Now, I told you up above here, in order for them to be inverses, we have to reduce to x. Well, technically, v is my x variable. They've just called it v instead of x. So this one checks out. We're good to go. Now I have to do the other route, and I have to do r composed of v. So instead, I'm plugging this into this function for v, right? Okay, so instead of putting v here, I'm putting this stuff into that place, okay? So instead of v here, I'm putting 5 pi r squared in for that, okay? And then I'm reducing to see what I have left over. 5 pi, those are going to cancel, because one's on the top, one's on the bottom. I can reduce that. And then I have the square root of r squared. The square root of r squared is r, okay? And so I said they are inverses if it reduces down to just x. Since r is our x variable, those check out. So because they've reduced down completely, and that's all I have left over, these two functions are in fact inverses of each other, okay? So this using composition, they'll say, using composition, check to see whether they're inverses. That's what you do. You plug one into the other, see if it reduces down. Plug one into the other, see if it reduces down. Now, this one, we only did the one direction. We only plugged this one into here, right? We should have plugged this one into here also, but because this first one failed, we didn't even have to do the other side. We didn't have to plug the first one into the second one because the first one already failed. So not inverses, we just get to stop. But here we checked both sides and they reduced down and everything came out really nice and clean. So they are inverses, and that's how you check that, okay? So here's what I want you to do for homework. Page 311, 2 through 22, the evens is what I want you to do. Number 14 is one that we're going to wait and do together. So do all of the 2 through 22 evens except for number 14. We will work on that one tomorrow, okay? So use the rest of the time in class to do that, and I'll answer questions when I come back.